Hey, my friend, Arthur Morris here. I hope all is well. In this video, we're going to look at bases other than E in applications. So the properties of inverse functions. Property 1, if y equals a to the power of x, or y equals a to the power of x, if and only if x equals log base a of y. 2a raised to log base a of x is equal to x for all x is greater than 0. And 3 base log of a log of a to the x power of base a is equal to x. So log of a to the x power of base a is equal to x. All right, number 1, log 1/8 base of 2. We want to express this expression without using a calculator. Now, what I would do, I would write this in, set this up as an equation. So we're trying to figure out what this thing is equal to. So you need to rewrite this using property 1 here. And we rewrite it as keeping 2 as our base, log base 2 of 1/8, keeping 2 as the base, bringing whatever's on the opposite side of the equal sign over, and it becomes the exponent. And then the exponent with the logarithm goes to the right hand side of the equal sign. So in other words, log base 2 of 1/8 can be equal to, or it's the same as 2 to the power of x equals 1/8. So you see the base stays the base. Whatever's on the opposite side of the equal sign comes over and becomes the exponent, and the original exponent goes to the other side of the equal sign. And then our goal here is to solve this thing for x. So what I would try to do is to try to get a common base on each side of the equal sign. So what we know is that 8 can be written as 2 to the third power. So that's the same thing as 1 over 2 to the third power. So if I want these on the same level playing field, I can move that 2 to the third power up to my numerator, changing the sign of my exponent. So 1 over 2 to the third power is the same thing as 2 to the negative third power. Now, if they have the same base, then you can set the exponents equal to each other to solve. Therefore, x equals -3. Therefore, log of 1/8, log base 2 of 1/8 is equal to -3. Okay. Number 2, we have log base 27 of 9. And again, I will set this up as an equation. And then I'm going to rewrite it. So my base 27 remains the base. The x comes over, becomes the exponent. The 9 goes to the opposite side of the equal sign. And again, I want to try to write these with the same base if possible. So I know that these both can be written with a base of 3. So 27 is the same thing as 3 to the third power. So that becomes 3x up there. And 9 is the same thing as 3 to the second power. So if I have the same base, then I can just set those exponents equal to each other and solve for x. So divide both sides by 3, x equals 2/3. Therefore, log base 27 of 9 is equal to 2/3. Okay, so again here, log base 7 of 1. Again, you're asking 7 to what power equals 1. On number 2, we were saying 2 to what power equals 1/8. Or number 1, 2 to what power equals 1/8. Number 2, we were asking 27 to what power equals 9. So number 3, we're asking 7 to what power, to the power what equals 1. And I put the answer there. Let's go back and put the x. So we can rewrite that as 7 to the power of x equals 1. Okay. And could I write that with the same base? Sure, I could. Don't have to, but I could, because I know that to equal 1, anything to the power of 0 equals 1. So I could write that 1 as 7 to the power of 0. It has the same base. And 7 to the power of 0 equals 1, because anything raised to the power of 0 equals 1. So x equals 0. Okay? All right, so here it says solve the equation accurate to 3 decimal places. All right, so if you have an exponent in your, and we didn't show it here, but if you have a variable in the exponent area, I think we've looked at this before. I know you've looked at it before in other classes. You can bring that variable down out of that exponent position by applying the natural logarithm. So here we have 3 to the power of 2x equals 75. I want to get that, I'm trying to solve for x, so I want to get it out of my numerator first of all. So first thing I'm going to do is to apply the natural logarithm to both sides of the equal sign. And from our properties of the natural log, we know that we can rewrite this natural log of 3 to the power of 2x by bringing this 2x out in front of the natural log. And then let's continue on solving this for x. So let's divide both sides by the natural log of 3. And then let's multiply by 1/2. All right, then we would plug that in our calculator, and the approximation accurate to 3 decimal places, 1.965. That's it. So if we have a variable in the exponent position, we want to get that variable down by using the natural log, applying the natural log to both sides of the equation. All right, so number 27 here. Apply the natural log to both sides of the equation. Now we can bring the 3 minus z out in front of the natural log. And then divide both sides by the natural log of 2. And then we can drop the parentheses there. And we're still trying to solve for z, so we want to subtract 3 from each side. And then divide both sides by -1. And plug that into our calculator and round to 3 decimal places. And you can make that 3 minus the natural log of 625 divided by the natural log of 2. So that gives us the approximation of -6.288. All right, and number 28, same idea. We want to solve for x. The first thing that I would do is to divide both sides by 3. And then I would apply the natural log to both sides. then I would bring the x minus 1 out in front. That was the whole reason for applying the natural log to both sides. Divide both sides by the natural log of 5. And then add 1 to both sides. And then calculate that in the calculator. And you get an approximation of 3.085. All right, now let's throw a little calculus in here now that we got that algebra review out of the way. Let's throw a little calculus in here. So it says that the derivatives for basis other than e that has a variable exponent, of course. It says let a be a positive real number where a is not equal to 1, and let u be a differentiable function of x. The derivative with respect to x of a to the power of x is equal to the natural log of a times a to the power of x. Now, if we have something other than that single variable of x, 1x or 1 whatever in our exponential position, then the derivative of a to the power of u is equal to the natural log of a times a to the u times du over dx. Or u prime. Okay, and then 3, we deal with the derivative with respect to x of log of base a of x equals 1 over the natural log of a times x. Again, if that x is anything other than 1x, then the derivative of with respect to x of log base a of u is equal to 1 over the natural log of a times u prime, du over dx, or u prime. Okay, so number 37 here, we can use number 1 that says the derivative of a with respect to x of a to the power of x is equal to the natural log of a times a to the power of x. So in this case, 4 is in the place of a, and then x, of course, is x. So f prime of x is equal to the natural log of a, or the natural log of 4, times a to the power of x, 4 to the power of x. Okay, now number 39, we need to use part 2 of that theorem. So let's let u equal negative 4x, then u prime, or du over dx, equals negative 4. All right, so and we'll write that just as they have it in the formula. Du over dx equals negative 4. So then you're just substituting from there. All right, so y prime sorry about that, pen got stuck on me. All right, so y prime equals the natural log of a. In this case, 5 is in the place of a, and then negative 4x, of course, is u, as we stated. So the natural log of 5 times a to the power of u, so times what you have here, so times 5 to the power of negative 4x times du over dx. Okay, and then you can clean that up some. So we have -4 natural log of 5 times the natural log of 5 all over. And since I have the negative exponent, I can move the 5 to the -4x. I can move that down to my denominator and make it 5 to the positive 4x. Okay. All right, number 41, we have x times 9 to the power of x. So we have to use the product rule here because we're multiplying two functions. So first times the derivative of the second plus the second times the derivative of the first. All right, so f prime of x first, or x times the derivative of 9 to the power of x. Well, we know that the derivative of 9 to the power of x is going to be the natural log of 9 times 9 to the power of x, then plus the second times the derivative of the first. So 9 to the power of x times the derivative of x, which is 1. Okay. So 9 to the power of x times the natural log of 9 plus 9 to the power of x. And you could factor that 9 to the power of x out if you chose to. I'm going to leave it like it is. All right, number 44, we have f of t equals 3 to the power of 2t over t. So here, I'm going to use my quotient rule to find my derivative. Low d high minus high d low over low low. So f prime of t, low, so t times the derivative of 3 to the 2t. Well, let's come over here. We know that u is equal to 2t, and then du dt is equal to 2. So times the natural log of 3 to the 2t times 2. And then minus high d low, so 3 to the power of 2t times 1, all over our denominator squared. Okay? And again, if you want to clean that up some, you can. Let's see here. Looks like I made my one mistake for today. Uh, that should be times the 3 to the 2t, and then times that 2. Sorry about that. And then minus 3 to the 2t times 1. Okay, so if you want to clean that up some, you can. Again, like I stated in the previous problem, I could factor out that 3 to the 2t like so. And then I would have 2t times the natural log of 3 to the 2t, and then minus 1. Okay, so if I factor that out, that would go away, and that would go away, and that would leave me with 2 times t minus 1 in the parentheses, factoring out that 3 to the 2t over t squared. And then it cleans it up a little bit, and you could have done that in problem number 41 as well. Could have factored out that 9x if you chose to, and that will give you x times the natural log of 9 plus 1. So either way would be okay. All right, number 51. we have y equals log base 5 of x squared, the square root of x squared minus 1. If we go back up to the previous page, we see that if we have log base a of u, that the derivative of that is 1 over the natural log of a times u of du dx. So we need to identify a and identify u and find our derivative of u. Okay, so let's write that derivative over here. So log base a of u is equal to 1 over the natural log of a times u times du dx, which is the same thing as u prime. All right, so let's see here. Let's rewrite this as y equals log base a, log base 5, and write this in exponential notation. Okay, and since we have a logarithm here, we can bring this 1/2 that's in the exponent form out. We can bring it out in front of the log. And then I can find my derivative of this. So we have 1/2, which is a constant multiplier there. So we'll leave that 1/2 as is times the log of 5, log base 5 of x squared minus 1. So in this case, a is equal to 5 from our formula, and u is equal to x squared minus 1, and du over dx is equal to 2x. Okay. So we have 1/2 times 1 over the natural log of 5 times u, and u in this case is x squared minus 1, times du over dx, which is 2x. So just following along with that formula, 1 over the natural log of 5 times u, which is x squared minus 1, and that whole thing times du over dx, which is 2x. All right, so those 2's cancel out from the 1/2 here and the 2. They cancel each other out, so it leaves me with x in my numerator over the natural log of 5 times x squared minus 1. Let's look at one more of those. One more problem like that one. Let's look at the example. Let's say we have f of x equals log base 2 of the cube root of 2x plus 1. Okay. So again, the first thing we want to do is rewrite this in exponential notation. So log base 2 times 2x plus 1 raised to the power of 1/3. And since we have that logarithm, we can bring that exponent out in front of the log base 2. Okay, so now we see that a is equal to 2, u is equal to 2x plus 1, therefore du dx is the derivative of 2x plus 1, which is 2. So f prime of x is equal to 1/3 times 1 over the natural log of a, so the natural log of 2, times u, we're letting u equal 2x plus 1, times du over dx, which is our derivative of 2x plus 1, which is just 2. All right, and then let's see if we can clean this up a little bit. So we have f prime of x. The 2 goes to the numerator there. The 3, we can bring it down to our denominator. So 3 times 2x plus 1 times the natural log of 2. Alrighty, my friend, that's it for this video. Hope you found it to be helpful, and I will see you on the next one. Thank you.